Today we are going to be talking about right triangle trigonometry. Okay? There's a lot of things that we can do with right triangles, but first we need to review some vocabulary and make sure that you remember right triangles. Okay? The side across from the 90-degree angle is always called your hypotenuse. Okay? Now, we have two other names that we can attach with the legs. So it's always in relation to whatever angle we're looking at. So this angle, we're going to call our angle x. So we have two things called the opposite and the adjacent. The opposite is across from the angle that you're looking at. Okay? So similar to how the hypotenuse is across from the 90-degree angle, the opposite of the rest of the triangle is across from the angle that you're looking at. So this would be labeled as opposite, and then adjacent means next to. So next to would be our either this side or it would be this side, but the hypotenuse always trumps the adjacent. So label your hypotenuse first, then you can find out what the adjacent is next to the adjacent, and then your other one is the opposite or across from the angle that you're looking at. Now if I were to reorient the triangle, or if I were to change which angle I was looking at, it would change what the opposite and the adjacent are. The hypotenuse always stays the same no matter how you twist your triangle or which angle you're talking about. If I changed and I looked at this angle, I would say that this is the opposite because it would be across from this angle that we were looking at, but it would be, this would be the adjacent because it would be next to this. Okay? So you have to make sure you know which angle you're referring to for our trigonometric values. Okay? So we have a couple of new words. One is called sine. Okay? Sine, cosine, and tangent. Now, we abbreviate sine, cosine, and tangent using three letters. So sine is abbreviated by using sin. So don't say sin. You want to say sine even though you're just abbreviating it with sin, which looks like sin. Okay? The cosine we abbreviate with the first three letters, which is cos. And then the tangent we abbreviate with the first three letters as well, so you get tan. Okay? So these are just ratios, which is what we've been talking a lot about. So the sine is the ratio of the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. Okay? So now what we have with this is some ratios that we can figure out. Okay? But there's a couple ways to remember this. One is called Sohcahtoa. It's just sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, so they just made it into a phonetical word. Okay. The other way that you could do it is you could write scat without the A, and then you could do, oh hell, another hour of algebra. So the scat gives you the sine, the cosine, and the tangent, then oh hell is opposite over hypotenuse, another hour is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay. The third way that you can remember it, and I don't care which way you remember it, you just need to be able to remember it, is with this sentence, some old hippie caught another hippie tripping on acid. I don't condone that. It is just a good sentence to help you remember. So sine is some old hippie caught another hippie tripping on acid. So Sohcahtoa from here, or scat, oh hell, another hour of algebra, or some old hippie caught another hippie tripping on acid. So one way you need to remember that the sine is the opposite over the hypotenuse, the cosine is the adjacent over the hypotenuse, and the tangent is opposite over adjacent. Okay? So now what we're going to do is we're going to set up a ratio, but we're just using one triangle, whereas when we've set up our ratios before, it was looking to compare if two things were similar triangles or to find a missing side. But now we can use these things called sine, cosine, and tangent, our trig functions, or trigonometry, to find a missing side or angle just given the piece of the one triangle rather than having two to look at. Okay, so let's take a look at our first example. Oh, these were supposed to be moved over there. Sorry. So let's just move these over here. So sine of A cosine of A, tangent of A. That was supposed to be for that problem. I fixed it at one point, but apparently Word decided to put it back. So the first thing that we need to do is label our triangle. Now notice these all say from A, so for this one, I'm looking from this triangle. Okay? So the hypotenuse is always across from the 90-degree angle. So this one's going to be the hypotenuse. If I'm looking at this angle, across from that angle is going to be opposite, and next to that angle is going to be adjacent. Okay? And I just used A and O and H to represent those three. So the sine is going to be opposite over hypotenuse, some old hippie or scat oh hell or so. Okay? So I take the opposite, which is 3, and then the hypotenuse, which is 5. I get 3/5. I can't reduce that, so then I'm done. The cosine is adjacent over hypotenuse. Okay, adjacent over hypotenuse, that's cot another hippie, or the scat another hour, or ka, one of those three. So the adjacent is next to, so that's the 4, and the hypotenuse is 5, so 4/5. The tangent is opposite over adjacent, or tripping on acid, or toa, or of algebra. Okay, one of those. Opposite is 3, adjacent is 4. Once again, I can't reduce those, so then I'm done. Okay, if we look below, notice all of these have the B value. So I'm going to use a different highlighter, and I'm going to look at this angle right here. So there's 2 different setups for each triangle based on which angle you're looking at. This remains the hypotenuse. This, however, is opposite because it's across from the angle B we're looking at. And then the adjacent is the one next to it. Okay? So now I can do the same thing. So what happens with our ratios is that they just flip a little bit. Okay? So the sine is opposite over hypotenuse. So, or you could do some old hippie, or you can do, oh hell, another hour of algebra. So, opposite over hypotenuse, the opposite of the pink one that we're looking at, opposite is 4, the hypotenuse is 5, so 4/5. The cosine of the pink one is adjacent over hypotenuse, so cot another hippie, or ka, or another hour. So the adjacent is 3, the hypotenuse is 5. The tangent of B, the pink angle that we're looking at, is opposite over adjacent, or toa, or tripping on acid, or of algebra. So the tangent is opposite, which is 4 of the pink one, and adjacent, which is 3 of the pink one. Notice again, I can't reduce any of these, and that's my answer. Now let's look at the next triangle. Okay. See if you can figure out how to do this one. Let's have you try and just label your triangle. Okay, let's see how you did on labeling the triangle. This is your hypotenuse when you're looking at A. From A across, so the 10 is going to be the opposite. The adjacent is going to be next to angle A, so it's going to be CA. Okay? So if I want to find the sine, so is some old hippie, or opposite over hypotenuse, or oh hell. Okay? It's opposite, which is 10 over 15. So I divide by 5, that's 2, and that's 3. Okay? Ka is AH, so adjacent over hypotenuse. Adjacent is the one that's next to it. Notice I don't have this angle. Uh-oh. Well, we know how to find the angle from previously. We're going to use the Pythagorean Theorem. So, down below I'm going to show some work for the Pythagorean Theorem. The hypotenuse is 15, so that's going to be 15 squared. See, hypotenuse 15 equals a squared, so I'm going to use 10 squared, and plus b squared. Okay? So I'm going to call this side b of the triangle, okay? Which matches up with our angle, right? So 15 squared is 225, 10 squared is 100, plus b squared. So I'm going to subtract 100, which gives you 125. So b squared is 125. So b is the square root of 125. Well, I can break down 125 to be 25 times 5, because there's 5 quarters in 125. This is 5 times 5. So I have a pair of 5s and a loner 5. So this side is 5 root 5. Okay, so now that I've found this side, now I can write the adjacent, which is 5 root 5, over the hypotenuse, which is 15. Notice the 5 and the 15 can reduce, so I get 5 goes into itself once, root 5, over 15. 5 goes into 15 3 times, so I end up with root 5 over 3. The tangent is going to be opposite over adjacent, or TOA, or whichever way you want to use. The opposite is 10, the adjacent is 5 root 5. Notice again I can cancel the 10 and the 5, or reduce them. So it's 2 over root 5, because 5 goes into 10 2 times, and 5 goes into itself once, so there's an unsaid 1 right there. But I can't have a root in the bottom, so I'm going to multiply the top and the bottom by root 5. So I get 2 root 5 over 5. Okay. Now, if I look from B, so let's look at a different color. So if I look from angle B, across from angle B, this is the opposite. Next to angle B is the adjacent, and the hypotenuse remains the same, even though I switched angles. So the sine of B is opposite over hypotenuse. So our opposite with our green angle is 5 root 5 over the hypotenuse, which is 15. Notice the 5 and 15 can cancel again. 5 goes into itself once. 5 goes into 15 3 times. So I get root 5 over 3. The cosine is adjacent over hypotenuse, so 10 fifteenths. 5 goes into 10 2 times, 5 goes into 15 3 times. And then our tangent, oh, I forgot to put adjacent over hypotenuse there. Our tangent is opposite over adjacent. So the opposite with our green one is 5 root 5 over the adjacent, which is 10. The 5 and the 10 can cancel. 5 goes into itself once, 5 goes into 10 twice. So I have root 5 over 2. And that's it. So you need to memorize somehow how to get the sine is opposite over hypotenuse, the cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. You need to remember when you're labeling your triangle that it matters which angle you're looking from. You're always looking from one of the ones that are not 90. You don't ever look from 90. Your hypotenuse remains the same regardless of which angle you're looking at. And then you just set up your ratio and you simplify if possible. This is Square Rooter signing out. Don't forget to answer your questions.